Hello and welcome to the fourth Gitaly training session where we look at how Gitaly fits into the larger picture of GitLab. Today we're going to look at Git push and Git pull over HTTP. We've looked at the SSH case already, so some things I won't be explaining again. And maybe we can get to things like merge commits and how those get created, because that's a third category of doing stuff that's sort of a natural follow-up to the topic, but I don't know how much time we're going to spend on Git HTTP. Before I give an overview of how Git HTTP works, I thought I'd just do a small little demo, because with HTTP, compared to SSH, HTTP is very nice tooling. For instance, something like mitmproxy, which is man-in-the-middle proxy. This is open source project that allows you to inspect web traffic if you can control, if you have sufficient control of it. And if we can do a git clone through mitmproxy and see what actually happens with the Git HTTP protocol. So let's try that. I'm going to be using a real terminal for this, not my fancy Acme, because mitmproxy is an ncurses application and you can't run curses inside Acme. That just doesn't work. Mitmproxy has a number of modes, and if you want to do stuff where you analyze Git traffic, I've learned you want the reverse mode. And so you start mitmproxy with -mode reverse, and you need to say what the upstream is that the real traffic goes to. And for now, just because it's possible, I want to show you that you can just intercept traffic, real traffic that goes to gitlab.com. Like this. Yes, there we are. So this is the mitmproxy app, and I now want to do a clone from for gitlab.com on a public repo. Now, mitmproxy is listening on its own port, localhost 8080. So I'm going to tell Git to clone from HTTPS localhost 8080. And this is a special Git environment variable. If I don't do this, then Git is going to say, hey, there's a self-signed certificate here, and we're not going to we don't trust this server. But you can tell Git to skip the certificate verification. And because I want this to be repeatable, I'm going to delete the GitLab test directory that's already here. So this should do a clone from HTTPS localhost 8080, and that will then actually go to gitlab.com. So on this side, it just looks like a clone. Simple enough. But now if we go back here, we see that two requests happened, a get and a post. And we can see exactly what the resource was. So the first part of our clone, this HTTPS localhost 8080, that got translated into HTTPS gitlab.com, because we started up mitmproxy in this reverse mode where it targets HTTPS gitlab.com. And the second part is the URL that Git makes its first request to. So it takes the base path of the repository and it adds /info/reps with a query parameter, service equals git upload back. And that's a get. And we get some stuff back. And then it does a second request, a post, to the same base path, but then /git upload back. Now, the cool thing is we can use the VI key bindings. Actually, can you use normal key bindings? Yes, okay. Well, I use the VI key bindings and I hit enter on this, and then I can see what happens. So it's a get in this case, so there is no request body. These were the headers. So Git is telling gitlab.com what version it is, not much else. And this was the query parameter. Now the response, in the response we can see all the response headers. Oh, by the way, I made sure to clone from a public repo, because otherwise in here would have been my HTTP basic authentication showing my password. So I'm going to try to remember to not show my gitlab.com password here. So the response of the get has this special content type, xgitload git upload back advertisement, and this looks like text data, but actually here you see \x00, there's a little bit of binary data in there. And this is called the ref advertisement, and here the server tells Git all the refs that are in the repo. So that's the response on the first request. And then I think I need to hit escape. No, I need to hit Q to go back. Then on the second one, we get a post. I hope this will now load. Okay, it's working. So the post has a body and a request body and a response body. So this has a custom content type that Git looks for. And it is a bunch of these messages where it says that it wants all these commit IDs. And it only wants stuff. It can also say that it already has stuff, and then Git would calculate a smaller pack file that only has the difference. But this is a full clone. And if we look at these commit IDs, let's look at the first one. There's a special thing going on here that there's some sideband data appended here. That's a hack in the Git protocol. So the first thing it asks for is E5649. It knows that exists because in the first request, here Git said somewhere, let's see, where is it? E56, here we go. E5649. You need to ignore the first 4 characters. So that reference was advertised in the GET request. So then in the second request, the client comes back and says, I want that commit. I don't know, I keep going into the sort. So that's the request. The response is going to be partially binary data, so not all of it would make sense, but you can see that there's progress information in here, counting objects. All this stuff gets sent back gradually as the response gets prepared. More progress information, compressing objects. Okay. Yeah, and here we have the start of a pack file. So the 4 letters PACK and then 0002 means pack file version 2. And so that's a magic header. And the rest of it is Git pack file data. And let's see, yeah, it's pack file data all the way down. So that's, okay, that doesn't work. That is the request response cycle. And I think it's a really cool trick that you can do this because you can look both at the stuff at the Git transport level, but you can also see these HTTP headers if you're trying to figure out why something isn't working or what's going on. That's very valuable. And just to protect myself from making mistakes, I'm going to restart mitmproxy against localhost 3000, which is my GDK, because my Git credential helper is not going to send my gitlab.com password to localhost 3000. So that should help. And then in here, we no longer, I can do the same clone because in GDK, I also have this repo at the same path, but I don't need the SSL no verify anymore. Take that off. And okay, it's still using HTTPS. We don't want that. Now it can still clone. You actually saw some stuff here in the background. Here you saw that post request coming in. So you can see it both on the server side and here in mitmproxy on the client side, that it made those same get and post. So that was my little preview of what happens in Git HTTP. Let's try to write some notes about what happens. So, okay, and we're going to only look at git clone because git push is slightly more complicated, but all the complexity of git push is the same here as it was with SSH, and we already looked at it there. So to keep this story simpler, I'm going to ignore git push. So what happens? A user runs git clone. git makes HTTP requests to get request to, and what is the user cloning? So, okay, copy. There's a, I hope you can see, I have the little pictures of the video here, but can you see the, is anything blocking this panel? Okay, good.
No.
Cool, thanks. So the first request is to info/refs, and it has this query parameter. One of the reasons for that is that, no, let's not get sidetracked by that right now. Server responds with list of refs and commits tags they point to. And then Git makes an HTTP post request to almost the same thing, except it's this. And server responds with progress messages and a PEG file. And what happens behind the scenes? So behind the scenes, this request gets it's intercepted by GitLab Workhorse. Workhorse pre-authenticates with GitLab Rails. GitLab Rails responds with Gitaly connection parameters, repository details, Gitaly network address, stuff like that. And Workhorse establishes, well, Workhorse makes a Gitaly RPC call and copies response into HTTP response body. And on the second one, it looks almost the same, except the difference is that Gitaly makes an RPC call, copies HTTP request body to Gitaly, copies Gitaly response to HTTP response body. Still with me? Cool. So what do we look at next? I think one interesting thing, maybe we should just go in order and look at how the request gets intercepted by GitLab Workhorse, which will force me to say what GitLab Workhorse even is. And then once we see that, we can look at how this pre-authentication happens. So what is GitLab Workhorse? GitLab Workhorse is a server-side backend component of GitLab that acts as a reverse proxy for the Ruby web server process that the actual bulk of the application runs in. And because it is a reverse proxy, because it sits in front of it, it can intercept any request it wants and do funny stuff. And we use it to offload slow requests from Ruby, because the Ruby web server process is relatively expensive, has limited throughput, uses lots of resources, and by having so we try to limit how much time we spend in there. And Git HTTP is actually the original motivating example for why we have Workhorse, because if you look at a clone, especially this part, if you're cloning a large repo, then in the HTTP response, you need to send hundreds of megabytes or gigabytes worth of data. And it's very expensive to do that with a Ruby application process. So that is not a good use of the Ruby application process. So we broke that down into, we only use Ruby to do database queries and look up if the project exists, if the user is allowed to access it, things like that. And then the rest of the requests, of the user's request, right? So the user wants to just get this, and we transparently offload the rest to Workhorse. And that frees up, this request response cycle is fast. So after this, the Ruby process can be reused to do something else. And this, yeah, like I said, this is why we made Workhorse in the first place, because Git HTTP was very unreliable when it was still relying 100% on the Ruby application server processes, because in particular, those have a 60-second timeout by default. So if your clone would take more than 60 seconds, it would be aborted. You couldn't clone a large repository over HTTP. So that's what Workhorse is. So concretely, it is a Go application, so it's hosted on gitlab.com, gitlab.org/workhorse. There's also, let me pull that up for a moment. If you look in the README, there's some background in a blog post we wrote. Yeah, there's a blog post, A Brief History of GitLab Workhorse, which is, it's already more than a year old, but it sort of gives you the story of how this happened if you want to know more about that. So Workhorse is the thing that is making the actual Gitly RPC calls. And it's a web service, so it somewhere has it's set up. It has a central router where we try to intercept requests, and at the end of the route table, if we didn't intercept the request for any reason, it gets proxied all the way back to GitLab Rails. So let's look at that route table, and that is in the internal upstream package. Bunch of helpers, pardon. We have a bunch of helpers here, and then here's the actual routes table. And because git clone was one of the first things, it's at the top of the routes table. I don't know if it's actually the most commonly called thing, but it's at the top. And here you see the things we are handling. So we have a get for requests that end in info-refs. We have a post for requests that end in git upload back. And we match on the content type. So any request that doesn't have that content type does not get intercepted by Workhorse. And then we have the third one. This one is for push. So git push and git pull make different post requests. And where does this go? Content encoding handler we can ignore. That's just a middleware. And this goes into git.uploadback or git.receiveback. So let's look for those. And that's an HTTP handler that goes into an inner function called post-RPC handler. Okay, more middleware. It goes with something called repo pre-authorized handler. And if that responds with something, this is an internal type, an API.response, then what is the handler? Okay, the handler is an argument. So it's one of these functions. What do these functions do? Handle upload back. I want to see this function. I want to see this function. So that function gets a Gitly client, and it calls the upload back RPC. Actually, this is an internal function that combines calling the RPC and copying the data. You can actually find that function. So this is just some glue code. I think we can ignore this one. Earlier, I looked for upload back. Internal. This one. Okay, this is an actual Gitly RPC call. Gives us the gRPC stream. We send a first request where we say what repository we want to look at. Git config options. This is something that gets injected from the GitLab Rails side. So we can set extra config on the upload back process. Git protocol is currently disabled, but it's a feature, it's an optimization internal to Git. When you use the Git protocol, how does that work again? v2. I can quickly show you in mitmproxy what has to happen for Git protocol. Okay, if I put -c protocol.version equals 2 in my command, then that will try to use Git protocol 2. So let me put that in there. So now this client is trying to make a Git protocol v2 request. And what happens is that here in the get, there's an extra request header that says version equals 2. And it's Workhorse's job to see that header, because Workhorse is the thing that sees HTTP. There are two layers to Git over HTTP. There's the HTTP layer, and then there's the Git transport layer. The HTTP part is invisible inside Gitaly itself, because Gitaly is not serving HTTP requests from the world. So Workhorse sees this Git protocol thing and does some checks to decide if that's allowed. And if it's allowed to use protocol version 2, we need to signal that here in the RPC request, because otherwise that information is lost. Okay, so we send a first request, and then we send a set of two Go routines, one that copies data from the request body into the stream, and the other reads data back from the Gitaly stream and copies it into the response body. So that's really all that happens there. This is the copying back and forth part that I've just shown you. This part makes Gitaly RPC call. So that's this. Copies HTTP request body. That's this. Sorry, this one, and copies Gitaly response to HTTP response, and that's this. So that's the three parts. This is roughly Workhorse's job. There's one thing we still have to look at, and that is this one. Workhorse pre-authenticates with Rails. I sort of glossed over that earlier because, well, sorry. Any questions about this part so far?
I have one question. Yes, in this part, you said that the Git config options there comes from Rails?
Yes. Workhorse is a dumb stateless thing. So when this request comes in, it has no idea what has to happen. It has no idea how many Gitly servers there are, no config about Git whatsoever. But I think maybe the Git config options will become a bit clearer when we look at the pre-authentication flow, because that's where that information comes from. Because there GitLab Rails response with connection parameters. So here I can add Git config options for GitHub. Oh, it's back. That's where that comes from.
Okay, okay.
Cool.
Because this is the handler that we call after the pre-authentication, right?
Yes, exactly.
Okay,
This happens first. So this has already happened. And we can't make this request because we don't know, we literally don't even have the network address of the Gitly server. We can't do anything until this part has happened.
Okay, clear.
Yeah, so this part is this, and this is relatively straightforward. So let me close that. And let's look at the other parts. So there was the post RPC handler, which returns an HTTP handler, and there's this inner function here, repo pre-authorized handler. So what does that do? Well, more layers. That uses an API.preauthorize handler. So what is that? Now we need to go to a different package in Workhorse. Some of the naming in Workhorse is slightly confusing because, yeah, it's a project that evolved over time and its responsibilities grew over time, and well, you know how it goes. We can't always keep up with. There's probably some technical debt in the naming here. Actually, we'll get to that. There's actually quite a big chunk of technical debt in how this part of Git HTTP works. yeah, so what this thing is doing, this is the API package, and there was a handler in here, the pre-authorized handler. This is the pre-authorized handler. So what does it do? It returns a handler func. So a handler func is just a function that takes with the signature of HTTP handler. So if you want to understand what this function does, you can ignore HTTP handler func. That is just some Go interface wrapping magic. This thing returns a function that takes a response writer and a request. It looks at the request and it builds. It takes the request and it calls this pre-authorized thing, which makes a call into GitLab Rails. So this is the actual part. Workhorse pre-authenticates with GitLab Rails. And two things come back: an HTTP response, or, well, actually, we get an HTTP response or an auth response. Because when we do this pre-authorization, two things can happen. Either we're on the happy path. In the case of git clone, that means an actual git clone is going to happen. But it can also be that there's a typo in the address, or the user isn't allowed to access the repository, or anything else, in which case Rails will just respond and say no. And then Workhorse's behavior is to take whatever the HTTP response was from Rails and copy that to the client. So if there's a failure, if Rails disagrees, the response is transparently copied down to the client. So that's why we get two things back here. One is Rails talking to Workhorse, and the other one is Rails talking to the downstream client. So if this is the case I was talking about on the unhappy path, if there's something in this thing and there is no, Rails is not telling us what to do, then we just need to pass back that response to the client and we're done. Otherwise, Rails might set headers and we're going to copy those headers. We'll get to this later. This has to do with authentication, which is good to look at, but not about sending username and passwords during Git HTTP. And then this thing just goes into the next handler, the next handle func. So then the question is, what does the pre-authorized function do? It takes the incoming request and it modifies the headers a little bit, and it replaces the request body. And that is because if this is one of these post requests, then the request body is Git transport data that needs to go to Gitaly. And we can only read that in an HTTP request, we can only read the body once, right? It's a network socket, you read once and then either you save it somewhere or the data is gone. So we just leave the request body sitting there. We only look at the headers and we derive an empty request that had the headers of the original request, and we forward that to the Rails backend. And that then tells us what to do. And if it tells us to go ahead, we still have the original Rails request from the client, and we can then copy that to Gitaly. So that's one of the things that this thing has to do here. So that's what this auth request thing is doing. And then it makes a request, does some counting, and it decodes the, so in the case that the Rails backend is telling us to go ahead, then we get a response body that is some JSON data. And that's, and that is that's how we know what to do. So maybe it would be good if we can see all this. Auth response is this thing. So what if now I would just say log? Can I log like that? Yes, I can. I'm cheating a little bit because I'm not supposed to use we use loggers mostly, but I actually find loggers very hard to read for this sort of stuff. So I'm just going to use the standard library. Printf. What do we want to say? We are looking at the Rails API auth response. And we want to show this thing. I think with the plus, we get some more details. Okay, now I save this, then go imports, we'll add the log package. Now I need to restart my GTK processes. Well, I need to recompile workhorse first. I think that is make GitLab workhorse setup. In this window, I'm at the top level of GitLab development kit. Why is this so slow? Okay, it's done. Now we reboot the app. Now this is the next why is this so slow. And let's see, if I try to make a new request now, it will just fail with a 502 because, and why does it fail? Because we're trying to make this pre-authentication request against Unicorn, which is a Ruby application which takes forever to boot. So we can't make requests yet. Let me clean this up because we don't care about protocol version 2 right now. Still not there. It's actually leaking quite a bit of information, but I think that's only because we're in development mode. Still connection refused. Okay, there we are. Now, before it gets lost, here, here's the get, and this is we don't care about this, so I'm going to delete that. Here's workhorse, here's the post. So here our first, okay, what happened on the client side? We have with mitmproxy, we can even see the 502s here. And here's the clone going through with get and post. So I now want to look at the server-side logs for these get and post. So this is the pre-authorized for get. And here you can see the actual get happening. And then this one is the pre-authorization for the post. And here's my log statement. Rails API auth response, and we get a big struct. And what's in the struct? Empty GLAD, empty username. You may remember these things. This is part of git push. And because we're doing a clone, these fields are not populated right now. Here's git config options. There's nothing. Here's a whole bunch of things that we don't care about, and that's technical debt, because we have one struct type for different types of responses from Rails, and they all get marshaled in here. So there's a bunch of fields that are completely irrelevant to git clone that are still in the struct. So when you log the struct, you get that information. So we don't care about LFS, remote objects, no. We don't care about archives or entries or terminals. We care about the Gitly server. So let's keep that. We care about the repository. Where does that end? That's all repository. And then this is also relevant to Git. So this is the relevant part of the API response. And that's this. Are you still with me? And
yes,
it's a lot, huh? And you can see this is similar to what happens in the GitLab shell case, because when you do a git fetch over SSH, there's this pre-authentication phase where GitLab shell makes an API call into Rails to try and get the necessary information to be able to establish the Gitaly connection. So this information looks very similar. And git config options, I don't think I want to go into what we use it for, because I'm not exactly sure, and I don't think it really matters to the big picture. But this is where it comes from. to answer your earlier question, Fran.
Okay. Okay. Thank you.
So this is the really critical thing where I was saying Workhorse doesn't know what Gitly servers there are, what they're called, where they are. It learns it by getting this thing. This is a repository object, so this is straight up Gitly stuff. You have the storage name, relative path. We talked about alternate object directories. Well, we talked about all this stuff last time. And I think this is something we use for geo-replication because there are some refs that you normally can't clone or they get sort of hidden for performance reasons. But when you do geo-replication, I think we do want to show them to the Git transport. So that's what that is for.
It'd be like the keep around refs?
Yeah, exactly. I think this controls whether keep around refs get shown at the Git transport level. So that's not up to the Git client. That is up to GitLab Rails to decide, yes, you get to see these or not. So yeah, that was some work, but we've seen this part. But I was promising you some nice technical debt earlier. Of course, the fact that I had to delete 20 fields here that are for other calls is also technical debt, but the cool part, if you think technical debt is cool, the cool part is when we look at how this works. So that is where in the Rails application we are handling these requests, because this is a hack that where you can really see we took on some technical debt at the time and we never got around to doing something about it. The requests that get made internally, I don't think these get logged. Maybe if you can bear with me through a recompilation cycle, we can log what the request is. So this is the authentication request. So let's do the same we did with the other one. So that was the auth response, and here we can show the auth request. Should have thought of that first time. Let's put that in there. And now quit this. We want that. If you have to do this lot, there's a trick. Let me show you the trick. You can edit the proc file and look for workhorse. And yeah, this is not the nicest way to do it, but what you can do, I can create a new window and take this command here that's used to run workhorse, which is quite long. And now this boots workhorse in its own window. And if I comment it out in the proc file, it won't get started here because we can only run it once. And now the advantage is that I can stop and start workhorse without having to wait for 30 seconds while the Ruby application boots.
But always I've done that. I always get the verify API request error with the JWT decode error.
If you run it in a separate window like this?
Yeah, in the presentation.
So I guess one problem here is that host and port are empty. Fran, I think if you have the exact same arguments, that should not happen. But there is a problem here in that host and port are missing. So this should be localhost 3000. And this looks better. Let's see if I can make a request. That looks like it's working.
Okay, I'll try again.
Yeah, another piece of technical debt in Workhorse is that we didn't put everything in a config file from the beginning. So some things need to be on the command line and other things need to be in the config file. You need to get it just right. That's why I just copied that line carefully from the proc file, because whatever, apart from host and port being wrong or being missing, it's right. It works right in the proc file. Okay, so I just restarted Workhorse here, and if I want to do another printf, I can restart it quicker. Let's try and do another clone. That's good. I see stuff happening. Where does it start? This is an authentication request. This is an authentication response. And this is the get. And then here starts the post. Response. And that's the post itself. Okay, so now we can see the request and the response. And we can compare it with mitmproxy. So let's look at the post for a moment, because this post got recorded in mitmproxy. It's this one. And you can see here that there is this request body on the post. And apparently it was gzipped. And the headers are hosts, user agents, accept encoding, blah, blah, blah. So now if we look here, then I expect to see the same things here. So we have method post, URL, upload back. This is some HTTP stuff. Headers. How far does that reach? Those are the headers. Body nil. Yeah, so this is the thing where I said we swap out the request body and we make sure that it doesn't get lost and doesn't get sent to Rails. And the headers are accept, application, upload back, user agents, Git 2.21. That's also what we saw here, the accept. And the content type is, where's the content type? We also took out the content type because actually the request we're making to Rails is not, the content type describes the request body. We left out the request body, so the content type would be no longer be a correct description of the request body. So that is the authentication request, and we already looked at the response earlier. Are you still with me? Okay.
Yes.
Now, the fun part here is that the URL, so this is the URL we're hitting on the Rails app, is actually the exact URL that was the inbound URL, because on the inbound URL here is also /gitlab-org/gitlab-test.git/git-upload-back. This is the technical debt I was talking about. So in retrospect, the smart thing to do would have been to make a clearly identifiable API endpoint, an internal API endpoint, where we can go and say, here's the URL the Git client wants to clone. You tell me what to do with it. But that's not what happened, because the way GitLab worked at the time was if you had one of these Git requests coming in, they would actually make it into the Rails application and get caught by the Rails application routes at some point. And then there was code on the Rails side which would spawn a Git process and do the Git stuff. And when we introduced Workhorse, we did not update those routes. We just changed the behavior of what happens at those routes. Instead of spawning a Git process there, we made it so that Rails just answered back with, here's the repo, you run the Git process. I'm not going to do this. And that means that if you look at the application routes of the Rails app, this Git stuff sits there in a very weird, random way. And it just makes life harder, the fact that it's there. So let's look for that. Unless you have any questions so far, let's look at where that is in the roots of Rails. How do I read this? It's been a while. I think the roots are split into files. Yes, so there's a git HTTP file. What is this? It tries to match on project paths, and it has roots. So I'm not sure exactly what these regexes are. Well, I know what they should be, but I don't know where they are defined. And we define 3 roots: get info refs, post gitlab, git upload back, post git receive back. So this is, we're just mirroring the real requests that get made. And these things go into the git HTTP controller. Which is this thing, which descends from git HTTP client controller. So if you want to understand what's going on, you need to understand 2 classes. Yeah, so I think we can leave this for what it is, because this is just a router. We end up in the git HTTP controller where we have a method info refs, upload back and receive back. That's everything it does. And what's access check? That either goes into the GitLab Git Access class or the Git Access Wiki class. And what is git command? Okay, this is probably defined in the parent class. Or not. How can we miss git command? Oh, here we are. So git command parses either the query parameter service, because you could see, you don't see it here. Here you see this part. So either it recognizes service equals git upload back, or it looks at the action name, which would be git underscore receive back or git upload back. And all that really happens here is this render OK thing. That's a happy path. If the request is denied, it gets caught by this before action. So the request comes in, and before we even reach this methods, this one gets run, which instantiates one of these classes. And then this thing runs a whole bunch of access checks that I think we shouldn't get into now. We can maybe look at them at another time, but they are almost not a Gitaly problem, I would say. They're more about the GitLab access control features and that logic, which you can, from a Gitaly point of view, this is a thing that says yes or no. And when we make it into this method, it has said yes by definition, because otherwise this method wouldn't be entered. And now we have this render OK thing, and this returns JSON. And this is a utility class that is specific to Workhorse, that creates the JSON data that then gets unpacked here into this struct. So this, from a Rails point of view, this is just saying your response body is some JSON data, and this is what ends up in there. But yeah, the infuriating thing is that these roots are all over the application, because if you look at GitLab or GitLab test, then this root is a user-facing web page, and it has completely different behavior, because if this would be a private repo, I would have to be signed in. So this thing would check my cookies to see if I'm signed in, right? Because that's how user sessions work, they're cookies. But Git HTTP doesn't use cookies. Git HTTP uses basic authentication, or maybe Kerberos, but let's not talk about that. That still piggybacks on the same mechanism as basic authentication. So we have this whole hierarchy of roots and stuff and controllers where we know, like, okay, if you make anything like these routes map to a hierarchy of Rails controllers, and those Rails controllers use inheritance to say at some point, here we do an access check against your cookie to see if you have a proper session and whatnot. And then in the middle of that, there's this random HTTP basic stuff that returns weird JSON data that is that contains secrets, because it will contain an internal access token to reach a Gitly server. So that is a secret used for internal network traffic that should never, ever leak to the outside world. And yeah, this is just in this JSON response body, and we just hope it doesn't get dropped on the floor and leaked out to the user. It would be much easier to reason about this system if it wasn't in the middle of all the other routes the way it is. Before you get worried, we do have checks to make sure that this data doesn't leak out. What we do concretely is that we set a custom content type on this JSON stuff, and there's a middleware in Workhorse where before a request goes back to the user, we check for this content type, and if this content type is set, then it is data that should never go to the user, and we abort the response. So we did think about this, but it's more complicated than it needs to be, and the reason for that is that before Workhorse existed, this thing, well, from a user point of view, this thing has to be nested inside the other routes, because as a user, actually, if you clone this, then GitLab will redirect to this.git, and this is what as a user, I expect my git clone route to look like. And then it's an internal detail that actually git clone traffic has nothing to do with, like this route has nothing to do with this route. And the user doesn't know this, and because of history, also in the application, it's hard to tell them apart. I don't know if anybody cares but me, but yeah, there you have it. It works. And I think that sort of covers this part. We also saw how the request gets intercepted, because that was that route table in Workhorse that I showed you. And we're almost out of time, so questions?
Well, not really. I mean, it's interesting, that last part. I mean, that we can, we also use Workhorse to prevent leaking some information like this. I mean, I've seen it to, I've seen Workhorse to replace, for example, some headers like the blob ID that we used to replace for real content and stuff like that. So it's funny to see this legacy behavior, and you wouldn't know why that chunk of code is there if you're not watching this video.
Yeah, exactly. So this is the thing I was talking about. Skip before action verify authenticity token. So that's one that would just completely break when you get an HTTP basic client, and this authenticate user is the thing that does the HTTP basic check.
Is the token signed for a specific project to be accessed?
No, it is a very, very, very permissive token. Once you have that token, you can make Gitaly requests to whatever you want on that server for as long as you want, until somebody manually rotates that token to become invalid.
Oh, so this is like a performance thing? Like we didn't want to issue too many tokens?
It's a simplicity thing. We had to have something, but we made it as simple as we could get away with. We actually, this is a complete digression, but we got complaints about this, and we started transitioning to a system where we have time-based tokens with just an HMAC timestamp scheme, where a token after a certain amount of time is just not going to do anything anymore. But there are some scenarios where we need to delegate the authority to make Gitly calls to one Gitly server, so that it can then make calls to another Gitly server. And we can't really put an upper limit. We don't really know what the upper limit is for how long that delegated token should be valid. So I think the conclusion is that we're going to roll back to the old system because it's more robust, but it is very, very, very basic. It's only suited for internal traffic.
Sorry, which old system?
So the old system is that there's a shared secret, and every request has this shared secret in a header, and it gets sent across the wire on every request. That is the first. That's the V1 Gitaly authentication system. And to make that more robust, we now have TLS. It's not deployed everywhere yet, but you can put TLS on the Gitaly backend connection. So even though that token gets sent across the wire, then you can snoop it there.
These tokens are in the config file, right?
Yeah, they are in the config file of each Gitaly server in the config toml, and in on the GitLab side, they are in the GitLab YAML, where we have this map. Where's this repositories? This thing. So the token would be here. And because the clients are stateless, the GitLab shell and workhorse are stateless, they don't know these tokens. So every time they need to make a request to Gitaly, stuff like this tells them what the token is. And then they use that for one request. They could remember it, but they're not designed to do that. So good question, completely orthogonal to the topic of Git HTTP. And we're sort of, we're at 1 hour now. Any other last questions? Okay, then let me see if I can stop the recording properly this time. In case this works, goodbye.